Hi, class. This week you are going to start learning about probability. And to do that, I'm going to do an example um, on the video for you so that you can do one independently. So the first thing I want to show you is where you're going to find all of this information. Um, if you are on our stats website, you're going to go to the section that says Part 4. And then, don't click that one, you're gonna go to the 14.1, how good is Miss H at free throws? The true answer to that is pretty terrible, but you're gonna do something with simulations and figure out how good at digital free throws I guess I am. The first thing that you might wanna do is just test out your knowledge of what is in a deck of cards. We're going to use decks of cards as for a lot of examples in this probability unit, so you might want to get familiar with what's in it. Even better than this, go play a game of cards of some sort with your family. After that, you're going to be watching this lesson. You're going to see the completed sheet right here. If you want to click on that and skip watching the video because you don't need it, you can. And then for you to turn in on Neo is this 14.1, how good am I at free throws? And there's going to be an essay assignment on Neo that you can upload an image to, a PDF to, a Google Doc to, whatever you want. So if you're having technical difficulties with that, shoot me an email and we can figure that out. So for the example that I'm going to show you, let me pull up the iPad. We are going to look at the probability of a red light happening at what I assume is maybe a lot of your, or used to be, your commutes to school. So we're going to look at if you're driving on Kennedy Drive and then you have to make a right into the school, what's the probability that the light is either going to be red or green? So this sheet is set up very similarly to the one that you're going to be doing for your homework for the week. So I thought I'd go through this so that you could understand how to do your sheet. So let's say every day you drive through the intersection of Kennedy and Dorset, and it seems like the light is never green. You know this can't really be true, but you just kind of have this feeling, this sense that it is. So first question having to do with just basic probability, is it possible that for some reason the light could always be 100% red? And you might notice I underlined possible. It is possible. Is it plausible? Probably not. They probably didn't set the light to be that way, otherwise they would have lots of trouble. So we could say possible, but not plausible. Is it possible the light is always 0% red? So 0% would be a possible probability. However, that also is not plausible. Let's just say possible, but not plausible. Could the light be 110% green? This one is not mathematically possible. So with probabilities, they can only be between 0 and 100%. They can't be negative numbers. They can't be bigger than 110% or 100%. So in order to investigate this, is the light really never green when we get there? We go out and we collect 10 days worth of data and we record it in the sheet below. So on day 1, the light was green. Day 2, the light was red. Day 3, the light was red, and so on. So what we do here when we want to calculate the probabilities for this, on day 1, if we had stopped collecting the data, we would say out of the one time that we collected data, the light was red one time, giving us a percent of 100%. At the same time, I can go and graph this and kind of look what it looks like on a graph. So on day 1, I had 100% green lights. for when I collected. All right, day 2, I'm going to have a total of 2 days that I collected. And then only one of those times was the light green. So on day 2, I'm now down at 50%. Day 3, the light was red, so I still only have one green light, so 33.333%. Day 3, I can put a little mark down at 33%, maybe about right there. Day 4, I still only had one green light, so we're at 25%. Day 4, 25%. Day 5, still only one green light, 20%. Then day 6, I finally get another green light. So 2 out of 6 would be same as 1 out of 3, so 33%. Day 6, back up here. Day 7, we get another green light. 3 out of 7, so 3 divided by 7 is 0.428, so 40, about 3%. Day 7, about here. On day 8, I got another green light, so 4 out of 8 would be 50%. Right there. And then day 9, still at 4, so 4 divided by 9 is 44%. And then day 10, final day of collecting, was another red. So 4 out of 10 would be 4 divided by 10. If you want to do it on your calculators, 40%. So as you can see in the graph, there was a huge jump from the first day to the second day, right? It went from 100% way down to 50%, and then it kind of jumps not quite as much between the rest of the days. So as the number of days increase, the probabilities tend to, I guess, like settle down. So if you maybe picture them going between 0 and 1, they kind of are a little bit erratic at first, and then they sort of tend to settle down into, I guess, what we would assume to be sort of the true probability. So based on the sample, what do we think the true proportion of green lights is? We don't think it's 100. We probably don't think it's lower than 20% because it never got there. So if we kind of say, it looks like maybe somewhere in this range, so maybe around, I don't know, 48%. Kind of our guess. And you could see that if we had stopped, let's say we stopped our sample after 5 days, we would have maybe had a very different guess than what we did if we had sampled for maybe 10 days or 20 days or 30 days. So when we want to make a prediction more accurate and we're looking at the cumulative probability of something happening and we don't actually know what the probability is, we get more samples. So if we collected this for 100 days or maybe 1,000 days, we might see that the probabilities do something like this. We might see they do something like this. We might see they do something like this. We can't really be sure without collecting that data. But what we can say is we can say we believe the cumulative probability would be closer to the true probability. So let's say we do that. Let's say we do it for 10,000 times and we get the cumulative probability is around, let's say, 43%. Interpret this probability. So what that means is there's not a 43% chance that every time we get to the light, it's going to be green. What this means is we believe that in the long run, this light will be green 43% of the times that we pull up to it over many trials. So the important thing to note there is that obviously when we pull up to the light, it's either going to be green or it's going to be red, or I mean, it's obviously, it could be yellow too, but we're either going to go or stop depending on how yellow it is. But with this, we're looking at the long-term results of many, many, many trials of this happening, not just like one time we see what happens. So this is what the big idea number one means. Interpret probability as a long-run relative frequency. So looking at many trials, what is the trend? In this, we also calculated some very simple probabilities. So the general formula for calculating a simple probability would be using a fraction. On the bottom of the fraction, you look at the total number of trials. And then on the top, you look at the total number of successes. And that term is kind of funny. So a success is whatever you're looking at. So in this one, our success would be the number of green lights. And then our trials would have been the 10 times, oops. We drove to the light. Another thing that you also saw, a probability has to be between 0% and 100%. You might also see these written as decimals, so it has to be between 0 and 1, right? So any decimal in between there. You can't have probabilities over 100%, even though we talk about that sometimes. And that, I think, is enough for the big ideas. So for your classwork, what you're going to be doing is looking at how good I am at free throws. So you kind of have a similar situation. You're going to look at me taking one shot at a basketball hoop then the second shot, third shot, fourth shot, fifth shot, all the way up to the 80th shot. And luckily, I don't actually have to throw these things. You're going to use this free throw simulator. And what you're going to do is you're going to very first thing, you're going to change the number of shots to 1. You're not going to click this, and then you're going to click shoot. So here, this says, if you read through this, I am claiming that I am an 80% free throw shooter, and you are going to test to see whether or not you think that is true or not. So you're going to shoot once. Down here it says, I did not make it. And then I'm going to do it again. I didn't make it again. So you can see this little blue line here shows you my cumulative percentage. So it makes that graph for you. I'm going to shoot again. Didn't make it. You might be thinking she's definitely not an 80% shooter. Again, didn't make it. Again, finally I made it. So on your sheet, you would be recording first shot, miss, so 0 out of 1. Second shot, miss, 0 out of 2. Third shot, miss, 0 out of 3. Fourth shot, miss, 0 out of 4. Fifth shot makes it, 1 out of 5. And then from there, it kind of gets tedious to write that over and over again. So you can tell it to make 5 more shots to get us up to 10. And you can see I made it 2 times total out of the 10. Let's do, what did it say? 15 I need to make, so I'm going to shoot it until I get 15. Still not looking like I'm an 80% thrower. Let's do another 5. Still doesn't look good. Let's do another 10. And you're just going to keep doing this until you finally make it up to 80 total shots. So as you can see, the number of hits I have is only 30%. If I were to do, I don't know, 100 shots, you can see how it's getting really, really hard for this line to even approach that 80% line that I claim to be true. So most likely it is not true that I'm an 80% thrower. As you can see, the line kind of like zigzags up and down quite a bit, but as I go out more and more shots, it's very incremental changes that it's making, and it's, you know, definitely not looking like I'm an 80% thrower. If I had to make a guess, it looks more like I'm around 30%. What you can do once you think you have an idea of the percentage that you think I am, draw the graph. How can you make your guess more accurate? You can click on that button that I said not to click on, show the true probability. And what the simulation does, it has some number in the background where it says this is the actual percentage, and it says hits or miss depending on what that simulation is telling it to do. So the simulation, I was really a 40% thrower. When you do it, you're not going to know what this percentage is. When I say new shooter, it resets that green line. So on your sheet, you're going to do that interpretation of whatever your actual percentages, fill in these big ideas, and then do this check your understanding. That is it. If you have any questions, please don't hesitate to check in with me about it.